All right, and welcome YouTube audience. We are live from straight out of space here at the Smash News Network, Least Busted Name and News, and we're bringing you a special edition of the Daily Space Weather today. This one is live. We won't only show you the space weather, but how it's made. So give us about 2 minutes. We'll be back in just about that amount of time. Here's a track. Make sure you press the share button in the meantime. All right, so this will be a little bit unlike any space weather video you've perhaps seen before, because it'll be not coming at you from the galactic core, but yeah, it'll be coming at you from the Milky Way galaxy, the regular part. So again, thanks to our YouTube audience, and you're going to get some insight into how many tabs we typically have open in order to make these videos. So thanks to our regular audience, any new viewers, if you're new to the channel, don't forget to press subscribe, etc. And this will be a little bit guerrilla-ish as far as the production, in that this isn't our regular live stream. So we typically live stream our Daily Space Weather videos to Twitch. We take them down, make them unpublished, and then they become YouTube exclusives, after which point they show up on BitChute. So anyway, first thing in the morning, and when we used to originally make these videos, we often started making them at about, I don't know, 3:30, 4 o'clock in the morning. It varies in time. It's usually before dawn that the videos start to get made. And the first thing I do is I bring up my browser. Now I have a special browser setting, and you can save your browser tabs. I've been using Brave to make the videos at the moment, but we sometimes use other browsers depending on the format. And you can save your tabs. So that's one first thing that I ought to tell you, that I have the same tabs there every day, although I don't use all the tabs, and I don't use the same tabs every day, and I put them in different orders, and there's all kinds of stuff going on. So sometimes we have as many as about 90 tabs open. And thanks for leaving comments, Bruce and Smasho staff. So we will address any chats that are super chats and any other ones that we need to talk about. So the first thing that I typically do is I'll look at the SDO magnetogram, make sure it's the latest image. And of course, to do that, always check the time and date stamps. So there you go, 3/26. It is indeed a current image. Again, there's the time and date stamp. Make sure you always check, because if it's not current, you might be given bad information. So that's the first thing I'll do, is typically look at sunspots. Now, sometimes it does depend on something else. Like if I know a flare happened as I'm part of Space Weather Twitter, right? Maybe I'll check out the X-ray flux. And so like in this particular scenario here, I might decide to show these flares, right? So what time did they happen? These last two We're between 1430 and 1800. So now again, to show you the tabs, I usually have Twitch all the way down at the bottom. I usually don't have YouTube here at all. And then I've got the X-ray outputs of Cygnus X3. I follow that regularly. It's actually in a low X-ray output state here at the moment, way down here on the graph. And Epic Pen just updated today, so we've got a thinner pen than usual. Oh well. We also look at cosmic rays regularly, so interesting 4-bush minimum there of cosmic ray flux. It was accompanied by aurora as far south as Phoenix, Arizona. Anyway, then what I'll look at is I'll pick up a custom image. So on the SDO data page, you'll find this link to the browse data. So in this case, I want to see what's going on, what part of the sun that flare came from, right? So I'll take just today. I'll pick a wavelength that's good at showing flares, like 131 angstroms, and then display today's images. I'm going to shrink it down so I can see the whole disk. And what did I say? Between 1430 and 1800. A couple small flares there in the C-class range. Coming out of the northern hemisphere, out of that sunspot, right? So let's say I want to show you YouTube folks a close-up of that. Then I would head to helioviewer.org and I would view the current data. Now, of course, there's a little conundrum happening here at the moment, and part of the reason why it's convenient for us to show you this now is because we've got old SDO data. So in this scenario, and there's going to be a lot of technical stuff in this video, so if you're not into technical stuff, then you're not going to like the video, I suspect. But we've got the GOES-R here instead of the SDO because, again, the data is not showing up there. So we do have at least one other HelioViewer site that we can check out, this one from France. And when we check that one out, keep in mind this one downloads a little bit slower. We can see it's the same data there. So it might be good to press newest or just press refresh. And indeed, it's showing us 2-day-old data there. 2-day-old data around the board. So what we'll do here is let's look at a composite. We'll look at 304 plus 94 angstroms. Sound good? I hope it sounds good because that's what we're doing. So here is we're going to just zoom way in on this sunspot from which those flares came, and then we're going to put today's date in, right? Pretty simple. 326. We'll do 1400 to 1800. Now, of course, we realize this would be a massive amount of work when we started the channel. And that's why we leveraged a whole bunch of different things to expect to have like 10 times the subscribers that we have by now, and hence 10 times the views. Or, of course, that's not always necessarily an equal thing, but let's take 2 videos of that same area and we'll slow one down all the way to about 10 frames per second. And then we'll also include, let's use some other wavelengths we don't always show, 284 angstroms along with 131. So you can see some great absorption features there already, some other elements there not lighting up in those wavelengths. That should show something interesting. And we'll also include, 304 angstroms all by itself. Now, of course, one of the conveniences that we have of making daily space weather videos is, well, frankly, it's not very convenient as we make them every day and they're like 40-minute long videos. However, it does allow us to show extremely detailed snapshots of all of the relevant information that's going on. So anyway, this is one of the things that I do when I start things out. I'll take today's data, press refresh, take today's data there, 326. I'll input, make sure it's yesterday through today. So there's the 25th at today's time, and that's yesterday, and today at today's time. 30 frames per second is the frame rate we usually use. It is the maximum frame rate because people have shockingly short attention spans and the ability to pause and slow down the videos if need be. So there's that. We'll also show, the coronagraph imagery, as that's always exciting. Now keep in mind there's going to be a gap between yesterday's video and today's. Again, because we're only showing daily data. We're not like trying to specifically pick certain times. We're doing 24 hours from when we made the video to make our lives slightly easier. And when you see me zooming in on the coronagraphs, we're actually including additional data there each time too, because we're using a higher resolution. And we'll just show 94 plus 131 angstroms, 24-hour. And for coronal holes, we'll actually just show the actual SDO browse data, right? So now I'm going to press F11, which brings me out of my full screen. And here's what I would do next. So if those were all of the videos that I was going to pick, right? Let's say those are all the videos I'm going to show you for sake of this demonstration. Let me vanish. So there are all the tabs I have open. And I would head to tab number 1, which is where I keep Twitch. And then I would turn on my white noise generator. So you know that warp sound that you hear on the videos? Yeah, you know how there's like a sounds like the Star Trek The Next Generation Enterprise at warp speed? Well, that's a white noise simulator. So we love our white noise simulator, and you know, maybe try it out yourself. It might help you sleep, and it might crash your PC, depending on which browser you're using. So this one's called mynoise.net. It's super good, highly recommended. Now, we don't donate to the channel, but it does accept donations. And so you can set this up how you like. And in fact, let's do this. We're going to actually share the white noise specifically used in this video. So we're going to actually put that in the chat. Just in case you want to use the white noise, you can share that with your friends and foes. That's the white noise we always use on the channel. And we've already got too many tabs open here that I'm unable to see some tabs, but that's okay. So here's the second last tab on my list, and that is the U.S. water vapor map. And basically the process you're going to see now is me going backward through all of my tabs as quickly as possible, so I don't have to refresh any of those while I'm making the video. Now, I'm not going to view the visible satellite on this. This will show you some ground features, which is totally cool. We don't usually show that because it's usually dark over like half the country when we put out the videos. So what I'm doing is I'm pressing Control-Shift-Tab here to go backward through all of my tabs, and it looks like we've got some weather here. Significant weather south of Shreveport. We'll get to it. We've also messed with the lightning mapper here and brought up some additional capabilities there. This was down on yesterday's video. I think we were looking at the Himawari 8 or something. Now this is the part where I have to make a decision each day, right? I have to decide what to display on windy.com. And today we'll be displaying snow depth. And there would be some more information about the deadly tornadoes in Tennessee. And then there would be the weather forecasts, right? So here I go to Tropical Tidbits. I go to Forecast Models. And we always use the GFS 72-hour model. It's usually quite accurate. I know some people prefer the Euro and other models. This is not direct forecasting. This is a quick fix for a large area. As if I was forecasting for a small area, you'd find that my forecast is shockingly correct. Cyclists like my forecasts. And of course, to be a proper time trial specialist, you better know the weather, or you'll have no idea what you'll be facing. Is it a headwind, a tailwind, a crosswind? You need to know. Anyway, here's where I would decide what to using forecasts, right? So I use the weather.gov map to help me figure that out. And it looks like there's going to be some, what is that? Is that snow? Winter weather advisories there. Oh, frost advisories and winter storm watches in California. So since we're showing snow also, let's actually do a snow forecast before we get to thunder and lightning. We'll do, okay, yeah, there we go. So I'll just click forecast GIF, pick my amount of time. I'll show pressure and precipitation. I won't save the GIF because it's pointless. I'll include also positive snow depth change and bring up the same model there. 72-hour model from Tropical Tidbits. That's what we show. There's a million things on Tropical Tidbits that we don't show. We keep it fairly simple. And today we'll show the visible satellite for once. We'll actually show the visible satellite over the Americas on today's video. And we'll even show you what we do like throughout the video. We'll actually do the video live on this video and then explain what happens after it ends, giving you ample time to leave additional comments. Speaking of your comments, we are seeing those. Thanks to everybody who's left some. And by the way, that's the OBS system that we use to stream and to record our videos. Next, I'll decide what to show on nullschool.net, and how about today we'll use, how about if we use surface winds and ocean currents. How about that? There you go. So you've got the animation there. And you got a low pressure system here in the North Atlantic hanging out. Anyway, it's looking pretty weak. Let's move on. Again, I'm just going through all my tabs backwards. We keep a consistent sizing on our tabs. And sometimes we notice stuff that we have to talk about when we do this. Other times we're noticing at the same time that you are, basically, if you're viewing the video live. And where are we now? I think we're on the ionosphere portion. For some reason, this site wants you to refresh it. We definitely were showing some interesting ionosphere anomalies, with just this side of zero incentive to do so. And of course, with predictive value, folks, you know, you got to look at two things. Is there predictive value in the first place in the academic literature? And secondly, does it add up to real-time observations? So there are ionosphere videos, diagrams, and we include the same tabs for reasons. It's because when you're looking at a meteorological forecast, if you're not looking at the same graphs every day, you're going to be very confused about what you're looking at, frankly. The videos are not designed to be watched just in a one pop, and you know, the educational level is approximately like high school physics. You should know high school physics in order to like have a fairly good understanding of the videos. So all right, so we're going to put on a slightly longer track here because, well, a couple of reasons. This would be the part where I go download the HelioViewer movies. So I'm going to actually skip forward because this is usually where I have the last one on the daily space weather videos. So now I've got to, now I'll go to HelioViewer, right? And I'll click on today's movies after shrinking the screen down because convenience. Right? And I'll download each movie, which is a tedious and frustrating process because these things are like 4 pixels high. Don't worry, I'm an endurance athlete. I can handle it. So, yep, then you download the videos, right? And there are different ways to do this. Of course, you could make a recorded video. That's a production. There's a reason why we do these live, because they are extremely timely. So the more live they are, the faster they end up on your screen. So that's why they're done the way they are. They could, of course, be done as complicated productions, but they are very similar to a meteorological video. It has to be in a certain time frame or it's going to be useless. So here is these are our custom flare videos. If you don't know how to use Helio Viewer, maybe some of our kind viewers will assist you if you ask a question in the comment. Not sure on that, but I did miss one there. Ah, crap. Which one was it? It was this one. And it gets super confusing super quick, folks. This one here, I don't even know. I think I made a duplicate of that one. Let's see. Yes. Just close that out. Resize this. And then I'm taking a break, so perhaps you should too. We'll be back in about 5 minutes on this one as we get set up to... This is when I would be getting coffee in the morning, as it would be done brewing now. So that's the way that works. Some little behind-the-scene production notes there. And again, thanks everybody for leaving comments. Again, if we see any super chats, they will certainly be addressed, and we'll display comments a bit. So now, I wouldn't normally be picking music, but I've already got music picked. Oh wait, I don't have music picked. So let's see. This one we're going to play Unified Theory 3. This is a track that is available all over the internet at Golden Cat Productions. And we'll leave you with some images of the Ghost 16 SUVi as that plays. And this time, I'm not going for coffee. Right, so the next thing I do is I would take our custom videos and splice them in where they belong. Now in this case, this isn't a normal DSW video, so we're going to put a 304 angstroms right here. And then continue to initialize all my tabs by just going through them backwards. By the way, if anybody knows what that is, here's a secret tidbit for you. Watch this. If you take a screenshot of a thing, you can do a photo search. So check it out. And of course, Google Images is a great choice, sadly. And that's not the right one. What is it? Reverse search. I never use this. All right, Tin Eye. Let's try that. Let's try Tin Eye. We'll say upload. I haven't saved that file yet. I'm going to save it via Twitter. We're going to show you how to find out what a photo that you don't know what it is. I think it'll work. So we won't name that because we don't want you to know what it is until we look it up. And we'll just drop an image in there. I'll bet that applet is live. Okay, it doesn't like it. Anyway, if you know what that image is, let us know in the comments. If not, sorry. Anyway, now we're on the part with where we show the solar filaments, the hydrogen alpha imagery, and this is part of the National Solar Observatory. We picked the one with the latest data. So today the winner is 154 engineering sites. What the heck? Okay. That doesn't look very good. We'll use Cerro Tololo. And there's the current filamentary situation. It is pretty intense. There are a lot of plasma filaments currently pointing toward the sun, which is of course something you take note of when you continue backward through your own tabs. Here's where I would add my coronagraphs. I just insert those in there manually. And then of course, never forget to set all of those to loop and not show controls. That provides a more seamless environment for people like you. So of course we have a different procedure for those that show date stamps versus those that don't show date stamps. And then here's 90 frames from the 2 coronagraphs that we show. We like to show stereo A, so we also show the Soho Lasco C3 here. And the current situation is, OMG, you're all gonna die. But probably not from this, because there's nothing exciting going on. Like, in all seriousness. Next we'll have our George Mason University stuff. I don't know why I'm narrating this. Anyway, this is what I do. This one we put the address in for whatever reason. And again, it's taken years to figure out which tabs to cover. Part of the reason why we started making the videos in the first place is because we noticed a lack of the information that we want to see. So, because there are certain things that we would like to see the physics tie together with. So that's always exciting when you see data and physics that make sense together. And of course, I always have to decide, before I made this video, I decided where I want the ads to be. You'll see those as I make a lengthy YouTube stream about how to make the video, and then I make the video, and then I tell you what happens after I make the video. Now here what I'm doing is I'm selecting yesterday plus today. And I'm selecting, actually, not 193, we'll use 211 angstroms. A little better at showing coronal holes. And the SDO imagery, we typically show at 67% of our browser zoom level, if you're wondering. Oh, I almost forgot to put in our solar flares wavelength, which goes right there. Here's our GO 16 SUVI 131 plus 94 angstroms. And then we've got sunspots. What the heck? Oh. Fortunately, folks, the SDO browse data works fine. It's just HelioViewer that's having issues, apparently, with the SDO data for whatever reason. Here we'll set it up to show, now for a special treat, we'll show 171 plus colorized magnetogram. So we'd like to, oh, well, I'm glad I checked. .94, 335, and 193. Come on, SDO. Oh, are none of them working? I thought the intensity grams were working fine. Oh, there we go. Cool. Anyway, that's why you check beforehand, because of a live streaming format. And of course, it makes things very streamlined if you're able to just get through all of the stuff without any slip-ups. Continuing on, let's see. Here's where we bring up the solar flare scoreboard and the ASAP flare monitor, which has been ASAP outdated data. Is it back? All right, it's back. Nice. So then I just size these so they fit on the screen correctly, and I don't show you stuff that I don't want to talk about. Because there are lots of things I don't want to talk about. For example, the Schumann resonances. Oh, don't get me started on the Schumann resonances. All right, anyway. So there, you got that set up now. Now we're going to have, we'll have 200 angstroms, 211 angstroms. Today I'm going to do the 48-hour video again. I like that because coronal holes are an interestingly evolving feature, and there's some evolving happening. Now some of the most interesting data that I'm interested in looking at. This right here is some of the most important stuff, the line of sight coronal hole plot. Highly recommended. Line of sight field plot is okay. And the top view ecliptic plane field plot is super important. Possibly the most important piece of data on the entire videos. As far as for, heliophysics and so on. And can you verify we're still live, Smash Staff? I like when I'm unable to view my own stream on the PC. All right, there we go. Cool. And I have vanished and I've reappeared. All right, no big deal. So, again, can't say enough about top view ecliptic plane field plot. For example, we've got north and south pole magnetism. See, we've got some south pole magnetic fields and some north pole coronal holes up at the northern heliographic pole. So always interesting. That's one of the best ones. Here's our earthly magnetic data from the GOES magnetometers. The real-time solar wind measured at Lagrange 1. For some reason, it decides to sometimes to change to a white background even though you have selected a black background. Could be the browser. I'm not blaming anybody. It's fine. Not a big deal. And it looks like we did have a little perturbation there, like a little minor CME strike. That happened right about when we would have been making the video this morning, I think. Oh, yeah. Solar wind density made it up to 36 there for a minute. So little CME events clearly happened. That was interesting timing. K-index, there's a K-index, just still going backwards through my, and we've got real calm conditions, so no need to show North America. Magnetic moment from space. Space Weather Enthusiast dashboard. Now I got to pick one more solar image. I think I have something. How about, instead of that, how about that? That's interesting. And let's see. That about covers it. We'll put this one here. There's one of our slow-mo images from the GOES-R. Here's our earthquake coverage. Now keep in mind, this is 24 hours. We don't adjust the calendar on this. It's 24 hours, and that's it. Looks like an earthquake swarm going on in the Caribbean right now. What's up with that? Puerto Rico. Some small quakes happen in Puerto Rico. Are they a foreshock? And are these videos economics videos? Yeah, in a lot of ways they are. Solar activity is perhaps the deepest cyclical that there is. Wouldn't you tend to agree? All right. So let me continue on here. How have I vanished? There we go. Now I'm back. So, you know, this is the tail end of my show prep. This is where I go, all right, I got to record the video now by streaming it live. So to make it as hard as possible, we stream the videos live every day. So here are the latest ones. We won't have to refresh these. We'll include yesterday plus today for colorized magnetogram. Yesterday plus today's imagery with... Come on. I want the 171 plus colorized magnetogram to work, but the 171 is going to be offline. So the AIA instrument may be having issues there. Oh, it did work. Nice. And then the images that we started out with. So let's see. What do we have to? What can we put up here? We're just going to show these close-ups. So this is where I start to get excited and I go, all right, we're going to put a video out. And then that one. And then I get to my first tab and I crack my knuckles and I take a deep breath and I say, oh, I have to talk to these rubes on YouTube now. Speaking of you rubes on YouTube, thanks for leaving comments to everybody who has. Again, we will address any super chats. No questions asked. And thanks everybody for tuning in, leaving comments, etc. We appreciate that. So yeah, I tuned that noise machine to sound like the Enterprise, the NCC 1701-D, the Enterprise of which Captain Picard was the captain in so many episodes of Star Trek The Next Generation. In my opinion, one of the best shows of all time. So anyway, it's got that relaxing feel like you're inside a room right next to a waterfall or whatever. So we'll just let these scroll here, and then we're going to start the video like a real daily space weather video, but after another break. So yes, thanks to everybody for tuning in to this odd behind-the-scenes conglomeration of information. Did you know that you can reverse search for images on the internet? I mean, this is not new information to me, but many people may not be aware of this. All right, so leave us a comment here. We're going to step away for another about 3.5 minutes this time. But here, you'll know exactly how long we're going to step away for, because I'm going to shop for one of our tracks. All right, let's play Settle It. And we'll be right back in about 3.5 minutes. And then the next thing that happens is I say something like this. Hey, welcome everybody to the Daily Space Weather, the most sustained feature of the Smash News Network, least busted name in news. And congratulations on realizing the channel exists. And I'd probably do something like this right before doing that, right? And then I would say, I'd be like, OMG, we're all gonna die. We're all gonna die because sunspot. Because remember, folks, sunspot is scary and lack of sunspot is scary. So don't forget. And I'd be like, look at it more closely. Oh my God, it's definitely going to kill you. Pardon my sarcasm. And then I'd show a different wavelength and go, that is even spookier than molten lava. And then I'd be like, just imagine if the Earth was suddenly submerged into molten lava. Somehow. Anyway, here's yesterday plus today. That's the next thing I would say. I'd be like, check it out. There's the magnetic fields and 171 angstroms all together in great colorized magnetogram. It's pretty sweet. Anybody who's mad at NASA and has access to this has got problems. I mean, that's, yeah. Now, if you'd like to argue with people who think that that is fake, make sure you join us over on BitChute, the official pain in the pelvic region portion of our content, as we regularly get, it's fake. It's like, dude, you can buy a $200 backyard telescope with a solar filter and look at many of these features, but it's fake. Okay. If you say so. If you say so. To quote the best character on Grand Theft Auto 5, and I say this regularly, if you say so. If you say so. What do you think about that, Smash Staff? She loves when I say that. All of your GFs and significant others will love when you say that. It doesn't sound dismissive at all. Pardon my sarcasm. It is biting. Anyway, we also then typically show the colorized magnetogram. Let's just show the regular intensity gram here. Since that 171 plus magnetogram is almost too good. Give it a minute. It's got to load a lot of images. They're 1024. They're 1024 by 1024. Oh, come on, SDO site. There we go. Nice. And part of the reason why our videos are not edited is because it gets them onto your screen almost instantaneously. So we do have some modest growth in here and up here. Whatever those sunspots are numbered. I could put OBS modules and things to put the numbers on the screen, but that's not the point. They're the daily space weather videos, not the, ooh, look at the production value space weather videos. Then I switched to volcanoes, and here's what's going on. I mean, I know people who fly planes. They might be interested in the flight levels if they happen to be flying over Stromboli or Shivaluch, which, by the way, doesn't constantly erupt. Sometimes it's a flight level 130, and sometimes it's a nothing. Krakatoa. I think I know a guy who's licensed to fly in Alaska. You have to basically be a meteorologist to fly a plane in Alaska. The rules are crazy, and they probably should be. Anyway, what else is going off? Krakatoa. Just don't fly over it. It's currently erupting, whatever the size. Merapi. phoenix clouds coming out of Merapi. Popocatépetl continues at moderate levels. No flight levels listed here. I don't know what's going on with that. Santiaguito mildly exploding. Don't pole vault the caldera. Fuego exploding. And look, we give our viewers a chance to interact with the Daily Space Weather video for once. That is rare. And we do see a super chat. What happened? Who is... How dare you? How dare you send us cash? All right. Evan says, Son of Clay says, Dan, how can you tell different kinds of sunspot formations, beta, gamma, etc.? What does that mean for flaring potential? By looking at the field complexity. I'll explain it in the high-res section. All right, so Santiaguito is also erupting. Fuego is erupting explodingly. I think I answered it in the comments section the other day, but that's okay. I'll explain it so everybody knows when we look at the high-res imagery toward the end of the video. Look, it's way over here. It's almost off the screen. Right here. There's where it is. So we're currently here. So if it ever seems like we rush through some of the information, it's because there's a lot of information. It's your condensed matter, and we think that you're capable of handling a bunch of information. So I guess that's a good reason to wear this hat, as it's I'm shining a lot of lights. So what else you got here? Fuego exploding in Guatemala, 16,000 foot ash plume. Sangay, 20,000 foot ash plume, etc. You get the idea. If you can see the screen, Sabancay is producing a 24,000 foot ash plume. Earthquakes. Wow, low earthquakes in the past 24 hours. So hopefully no foreshocks of major events in Puerto Rico, as we don't want Peter Schiff's house to collapse. Although if it does, he probably has a backup, because that guy is prepped. Peter Schiff is prepped. He's beyond the level of prepping he needs to be prepped. But if you have Hillary Clinton scale money, then you'll be pretty prepped. 5.4 in Chile is the first one we'll report on. It's over a 5, and then I'll just scroll and go, whoa, there's another one. So 2 5s in Chile. Maybe those are foreshocks. And I believe because of the ionosphere, did we not forecast an earthquake over western Mexico? I think that was a thing. So not often done on the channel, but I believe that was a thing based on ionosphere and total electron contents. Anyway, keep in mind, could be foreshocks. Next, this image that we refuse to tell anybody what it is. And again, don't worry, Evan, or Son of Clay. I will indeed. Oh, okay. I'm almost going to say the exact same thing I typed in the comments. So, all right. So, yes, I do have the chat here, as well as able to be placed on screen. So, all right. Anyway, I'm not telling anybody what that is. Let's get back to space, as we've talked about planet Earth. Here are a couple of little C-class flares there happening. And the radio flux is now at 160. Something I wanted to bring up yesterday that I forgot is we have a serious support level here at 155. So right here, just like if you're looking at a stock chart, this thing is about to break out. All right? Stock charts behave like this, and so does solar activity. In this instance, it doesn't always behave like this, but based on this utterly cherry-picked portion of an annual graph, the sun is about to break out and get into higher levels than this measly 234 thing. And I think most esteemed colleagues would agree on this, the radio flux is about to rise. Because, I mean, if you look at the overall graph, and anyway, I won't get hung up on that. NOAA forecasted a little bit of geomagnetic unrest today. And, yeah, nothing to say about that. There's a coronal hole high-speed stream. But besides that, not a lot going on. Coronal hole high-speed stream's kind of weak. Here's the past 4 hours of a simulation of the likely magnetohydrodynamic pressure of Earth's system at a macro scale to like 12 Earth diameters. This is the part where I'd say, look, that's 4 hours. Because that's just what this run includes. I'm not aware of any way to access a 24-hour data run. Maybe I should email them. They may provide me a way to do it. Next, global magnetic perturbations on the ground. Those were magnetic perturbations in space from the perspective of magnetohydrodynamic pressure. This is magnetic flux density on the ground level. And here's a perfect example of how it's refreshed. We're going to let it play through to get the most current data. And of course, a continuous 4-hour run. Next, we've got the KP index, which is currently quite calm and a measurement of global geomagnetism. Real-time solar winds next, and we put this frame up for a reason, because some people don't seem to understand that when we talk about the solar wind, it's measured out here at Lagrangian point 1, outside of Earth's magnetosphere, because it can't be measured inside the Earth's magnetosphere, because these charged particles are very diffuse. Even when they're dense, they're still very diffuse. They're like 1/10 quadrillionth more diffuse than the amount of air at sea level. So the protons per cubic centimeter at sea level, I believe, is something like 40 quadrillion protons per cubic centimeter. And out in space, they're like 6 protons per cubic centimeter. See what I'm saying? That's why solar wind isn't anything like wind. The wind that you experience on the ground in the troposphere, where all of your weather occurs, it's nothing like that at all. We're measuring a tiny voltage in order to... Anyway, it's measured at Lagrangian point 1, and the spacecraft that this covers are the ACE and Discover. So at the moment, see it says right up here, active is the Discover. So now if you look at the bottom line, for some reason the ACE isn't active. But anyway, we do have some indication of a CME impact, because we see a change in the plasma temperature, the speed, and the density all at the same time. What is strange is we don't see any shift here in the magnetic field or the phi angle. At the end of the event, we do see a little spike toward the negative in the BZ, but besides that, it's pretty minor. And then you see a similar signal here. So that's probably a fleeting event. I don't know. That's my analysis. It's a fleeting event, like a minor CME impact, perhaps. GOES magnetometers here in a tight range. There's only about 60 nanotesla of range in this short period of time. So those are geosynchronous near equatorial satellites. Of course, they're measuring the field at their location. Now, this data is from 51 ground-based solar observatories that look at light polarization to determine magnetic field orientation, and magnetometers out on stereo A and B. And what's super important about this is that it shows us the plasma interaction between the solar polar fields and the heliospheric current sheet. It's pretty serious. So when we talked about things like sector boundary crossings, there's the North Pole versus South Pole current sheet. Over here you've got the South versus North. But what's more important than that is that it shows us big fluctuations in magnetic fields. So it shows us you can see some activity happening right here. As when you see abrupt changes in the plasma, it is typically from things like coronal hole movements, or it could also be from sunspot formation or evaporation, etc. Also, CMEs are sometimes somewhat represented here if they also occur at a major orientation of the fields. But most importantly, it's showing you the polar magnetism. So here you've got South Pole. Here you've got North Pole. And those are both hanging out at the north heliographic pole. Here's some South Pole magnetism at the South Pole. And here's some North Pole magnetism at the South Pole. Right up here, you see those dotted lines. So, the field switch does happen sort of gradually from both sides. But we've got an awful lot of North Pole magnetism at the North Pole. And not a lot of it at the South Pole. So again, still a long way to go to get to solar maximum, which is sort of the moment of maximum field strength ultimately is just a series of magnetic measurements. Speaking of which, here's a line of sight field plot. We show it daily. The sun's B field. When we show the geospace delta B on Earth, it changes to the Earth's B field. These lines are associated with the sun's B field. And then most importantly is the coronal hole line of sight field plot, which shows you a proper representation of the solar polar field migration. I mean, right now, you've got these radio jet features that are South Pole. Then over here you've got North Pole radio jet features. And of course you can see the sector boundary crossings represented by those blue lines. A good visual is provided by the SDO. The 48-hour videos do work from the SDO website. So these are current images. 24, 25. There's today. All right. Yeah, so that's a proper 48-hour video. Next is the point where we go to sunspots. So, of course, another important feature of solar cycles and solar activity in general is the ever popular sunspot feature, counted for hundreds of years and visible to people with very primitive telescopes, even sometimes visible to the naked eye in certain situations, I suppose. We don't recommend doing such things. That could be very harmful. Please do not look directly at the sun. There are solar shades you can get that are rated to allow you to look directly at the sun. You would use those for an eclipse, but you can use them to look directly at the sun at noontime, if you like, as it has to provide that amount of filtration. Anyway, that's what's currently going on, and it's a thing. likelihood of large solar flares is kind of high. And again, we will get to the classification of sunspots here toward the end of the video. It's really not too tough. I mean, I'm going to recite it from memory without looking anything up. So if I'm wrong, it should only be minorly incorrect. So let's bring up, let's use the gray intensity gram. So that's yesterday plus today. So the entire day yesterday plus today's data so far. And let me get off screen. So, I mean, no matter how you look at it, there are a lot of sunspots there. And I think we're going to see a big uptick in the radio flux in the sunspot number here. I think somebody's been miscounting or something. I don't try to count sunspots because the counting convention is very odd, and I'm not going to get into what's a sunspot and what's not a sunspot. But that is an exceedingly large number of sunspots, especially for how low the radio flux is. The radio flux is shockingly low, and also the X-ray flux. So no energetic particles. And by the way, speaking of that, energetic particles, some great energetic particles come in the form of the hemp lucid particles. So check those out. You can find a link below the video to those. And if you want to support the Smash Team, check out smashomash.com/Smash Team. We launched a subscription services site to make things more accessible and better to our viewers back in October of 2021, because frankly, the online situation has been a little bit suboptimal. So we decided to, rather than complain about that, we decided to start making our own subscription services site and so on, because it's been less than conducive to putting out content in many situations. Not exactly sure, but it's Troll McClure. You don't know what the radio flux is yet? All right, maybe we should get to that. But anyway, so McClure, the radio flux is a radio signal that comes out of the upper chromosphere and lower corona, and it's very proportional to sunspot number. It was discovered back in 1947 by some Canadians who were messing around with some World War II equipment, and they started to notice a signal, but only in the daytime, and they realized that it was a very specific frequency, the 10.7 centimeter radio flux. It's vibrating hydrogen is what does it, and it's directly proportional to the sunspot number. So high radio flux, high sunspot number, and vice versa. So that's a quick little, that's basically what the radio flux is. And now normally when we show the Smash Team page, right, here's a little interesting tidbit for you. Normally when we show the Smash Team page, it's got the video playing right here. Why? Because it's streaming live to Twitch. We don't tell you that every day. It just is there streaming live. That's why we get that effect. And it's just a cool thing that Smash staff did. I mean, we didn't have to embed that there. And there are all kinds of other things we could put there, but it's part of smashomash.com. And, you know, we realized that we would have to fund our operations years before we started to get sort of serious about it. So we created a massive web ring, starting with smashomash.com in 2019. So at that point, we realized that we'd been sent to a maximum security social media stockade for crimes we didn't commit. You know, social media nonsense crimes that aren't crimes, but you get banned. So we'd, promptly escaped by making our own websites. So that's why we created the entire online realm. We already had the forum, but we didn't have the Smash Team site yet. So we You can find links to all of that stuff there, including the aforementioned Hemp Lucid Shop. Today's featured product, which is something I select each day, by the way, not necessarily at random, and something also not necessarily at random, is this. Did you know it used to be our best seller? Do you ever recall being right about stuff for an extended period of time and have people attempt to gaslight about you? Attempt to gaslight you about the stuff? We certainly have. Anyway, on a related note, part of the reason for our channel is to help make Earth not suck again. Because as you may have noticed, especially since, let's say, the Ides of March 2020, you may have some issues with the, functioning of the planet. A lot of bad decisions have gotten made, and a lot of accountability has not occurred. You may wonder why. So do we. Which is why we would remind you that it is your job to make Earth not suck again. So, and by the way, thanks for not pole vaulting the Caldera. If you sort our products by newest instead of best selling, which is the link you'd see below the video, this is the order that you'd see the products. Ooh, when will you stop believing NASA's lies about a croissant Earth? Make sure you tell your friends and foes that you're in a bunker because of the galactic current sheet. They'll be much less likely to eat you that way. Congratulations on surviving all the way into 2023. Thanks most of all to the Smash team at smash.com/Smash team. And then we would talk about the X-ray flux, right? That would be the next thing. And then I'd go, we had a double peak flare happen there, a little double flare coming out of that little C-class flare. And then we'd go, that's not really too significant. And then maybe it was these flares. I don't know. They're small enough that it's, who really cares? I mean, the last time we had a major solar uptick, the background X-ray flux was at it was almost at an M-class background X-ray flux. There was a point where just a flatlined X-ray flux was like C 5.6 or something. It was like way up here. Anyway, we show that imagery because it's good at showing solar flares. It shows a part of the corona that highlights them. And then we say, hey, here's a star chart, because we're going to show coronal mass ejections next, so we want people to understand where things are. Right now, Venus is practically directly overhead over the Lehigh Valley, Pennsylvania. Coincidentally, we love that you've tuned into the channel. You've also got the moon up there, the sun, Mercury, Jupiter, Mars, and Saturn just setting in the west. So that's what's going on overhead Lehigh Valley, Pennsylvania, where we're located. And that is quite a good star chart indeed. And here's a solar system diagram, not to scale. I say that all the time because people think Saturn and Jupiter are about to bump into each other when they're shockingly far apart. I mean, every time I show the to scale view, it like messes up the whole. Hold on, watch. Boom, to scale view. Is it? That does not look to scale. Anyway. The diagrammatic view is showing you that people think planets control the sun and that magnetic fields control planets' orbits and things. It's berserk. Anyway, that's why every time I look at this, I kind of want to laugh, because it's... All right. Anyway, then we show you a 1 week forecast so you know where things are. Is that a week? I can't count to 7. Counting to 7 is a really hard thing. See, if you go backwards, oh my God, it's yesterday. So yeah, there's today. There's April 2nd, the day after you might have been an April Fool. Then some coronagraphs. And those are fairly... Oh, wait. There are yesterday's. Those are fairly uninspiring. There are today's. Not that exciting. And the stereo A view, and we show this frame because we want people to know that stereo A is not way out at Lagrange 5. Stereo A is about to blow past Earth and be showing old space weather like stereo B ought to show, and not, yeah, it's a thing. Anyway, there's the view. And like when we showed Mercury, it was a perfect example of how close stereo A is to the Earth, which kind of sucks, especially when you're trying to forecast the trajectory of a coronal mass ejection. It's part of the reason why we couldn't see the stealth CME that happened, because, you know, it caused a KP7 plus, and we barely realized that it was happening. So the CME can hide behind the coronagraph, and if it happens when other events are happening, it can be very difficult to realize that it's, you know, directed toward the Earth. Anyway, these are 24-hour videos, I think. Yes. Coming at you very late today with these. And of course, our rare YouTube live stream. There's a close-up view. That's instead of the typical SDO 304 angstroms, that's the GOES R at the same wavelength. Not earthly directed. So here's filaments from Cerro Tololo, Chile. Say that 12 times real fast. Cerro Tololo, Chile. I can't say it. Huge number of filaments here. So there is one there that looks like it did something, but I think it might have collapsed or maybe just reoriented itself. It might be in the process of ejecting now. It's all over the place. It's become a phantom. And then we talk about naming filaments. We like to name them after living people on Twitter. So make sure you follow the hashtag name that filament and space weather. Twitter, if you intentionally look at our profile, you might see our tweets. Thanks to our new followers over there, by the way. We're almost as surprised that you found or saw the tweets as we are that you found or saw the YouTube videos. Now's where I might go, oh my God, no! The Superchats! We didn't forget about They come at the end of the space weather portion right by the meteorology segment. No, we're gonna die. That was one of our Klingon viewers told me to say that or something. We got like an angry jack-o'-lantern thing going here, by the way. It looks great. I mean, there's a great at this zoom length, there's a great depth to this. Anyway, one of the great things about when the SDO goes down is you end up seeing data that you didn't otherwise know about. Here's the past couple of hours, and that could be a CME happening right there. See that? A little event happening right there. That could certainly be. That could be an Earth-directed one. So, I mean, this is one of those things that if you're not looking, you might not notice. Lots of choppy fields. You've got South Pole coronal hole, South Pole coronal hole. That's a North Pole coronal hole, I think, up there. And then you've got, well, whatever. Anyway, that's the past 2.5 hours approximately. And that could be a CME right there. You see this filament, it's there, and then part of it's gone. So that's a lot more material than it may seem like. And let's continue on. We don't want this video to be too lengthy. Now we're into bonus features. Satellite charging hazards are non-existent. Turmoil on the sun, but calm on the Earth space. There goes electron flux here in a fairly normal range. Did get a little higher than we may have expected. There goes 18 there, showing warning range. And there's the forecast, way above the forecast. As there is indeed, excuse me, there is indeed a coronal hole high-speed stream continuing. So it's pretty minor, though. So a little bit of an electron spike there, and you've got multiple events overlapping here. So this is not super uncommon, seeing a little unexpected electron spike. I'm not particularly surprised about that. And let's see what the ionosphere is doing here. Where that's measured is about 300 kilometers. And we'll have to reload a bunch of stuff here because the video is getting particularly lengthy. We don't usually spend a lot of time talking about chats. So there is the vibrational frequency going on. And there is the anomaly. And we're seeing a lot less low frequency anomalies here. Although some significant ones there over Western South America. So, not sure if that has any predictive value, but some significant anomalies over the Atlantic Ocean also. I'll let that play through for a minute. As many YouTube viewers, I believe, need to let this sink in. Because indeed we do see a lot of silly comments about forecasting of earthquakes. So, we show the data, the full day of data each day. You would think that if you're able to forecast earthquakes, people would do it based on this exact data. So yeah, that data right there, your claims that you're going to forecast earthquakes ought to be coming from that YouTube, quote, content creators, end quote. Yeah, huge anomalies showing up there on the map. I don't know what to tell you. This area right here. And we'll see if we see continued anomalies on the electron flux. Now keep in mind, once again, this is the most geomagnetically active month of the year, and we've been having events. So there's going to be plasma out there, and let's see what's going on in between the GPS satellites and your handset with the total electron content forecasts. These are the free electrons expected to be between your handset and your GPS satellite, thereby refracting your signal. And it's looking quite normal here, as is typical of times with relatively high electron flux. We see this more constrained to the equator at times of high electron flux. We do see some nighttime anomalies happening. So not here, but must be right there. Right at the end of the run. So we're seeing some nighttime anomalies kicking up right now over, what is it? Around, there you go, the Indian Ocean. Anyway, here's North America. And this is one of the other features that people claim is able to be used to forecast earthquakes. So we show it on the channel, the total electron content. We show it for a very specific area. What the heck? What kind of weirdness is that? Little blank spots. Okay. Anyway, we saw some anomalies on this and the US one, and they were high electron content anomalies. Those have now subsided, but keep in mind the pre-earthquake signal that people claim is able to be legitimately used to forecast earthquakes is like a 4-day window. So when you see it, it's 96 hours. At the moment, things not looking too anomalously here over the U.S. Before we switch to meteorology, we usually show these high-res images, because those, well, they're the current images. Then we talk meteorology, and we're showing now ocean currents and surface winds. We're going to switch to mean sea level pressure. So we got this great low here. It's large, but it's not super strong. Most powerful low in the world is, I think, this one. 959 hectopascals. 957. All right. Anyway, we usually close out your space weather non-blankographic videos with Earth non-blankographic videos. surface winds, but not usually ocean currents, usually just wind. So there's wind. And then there's jet stream. The jet stream is usually at like 30,000 feet of altitude. Next, of course, this part of the planet, you get the idea. There's the data, there's your low pressure. There is your whatever. Visible satellite over the Americas. We'll reanimate that to get the latest. And that was your unexpected break. Here's the U.S. We got severe storm warnings once again for the southeast. Weather.gov is the site I'm talking about as my voice gets shattered. 72-hour snow forecast features another 2 feet of snow for portions of California. Large portions. And pushing 3 feet in some areas. DAG. Pressure and precipitation based on the 72-hour GFS model are depicted here. Oh, and Son of Clay, I hope you're still watching because I seem to have forgotten something. Let me get back to that. Let's talk about sunspot classification since you brought it up. Oh man, you better still be here. Or viewing in syndication. So, an alpha class sunspot is a sunspot that has only one polarity umbra. So this one right here, let me do that again. That one there, it's only got one polarity umbra. It's in the south. It's in the south heliographic latitude, and it only has a South Pole umbra. You see, only one umbra there. I mean, maybe you can make the argument that this is a North Pole umbra, but it's only got one well-defined umbra there. Let's just say, for sake of argument, that it is an alpha-class sunspot. That would be why, because it only has one magnetic field polarity. Got it? Next. Let's pick a sunspot that's a little more magnetically complex. How about this one? It's got both polarity magnetic fields. It better. Don't go alpha class on me. Okay, it does have a tiny field here. I'm not trying to be biased, but look, we see some dark spots right here. For sake of argument, let's say that's two fields and they're not super complex. That would be a beta class sunspot group. Now, if you had a lot more of these magnetic fields in proximity to the opposite polarity umbrae, it would be a beta gamma delta class. This would be beta gamma class. Let me show you this one here. Oh, geez. Where am I going? Oh, there we go. There are bad examples. Okay, here's a good example. Yes. So there's a perfect example of a beta gamma class sunspot. It's got both polarity umbrae, but it does not have a massive amount of magnetic field complexity with respect to the opposite polarity sunspots. So, like, the area in between especially is what matters. So, if there were a lot of South Pole fields mixed in here, for example, or if there were a bunch of North Pole fields like this in these areas, that would make it much more magnetically complex and likely to produce solar flares. So that's a beta gamma class sunspot. If it was more magnetically complex, it would be a beta gamma delta class sunspot. Beta gamma delta class means it is in the state of change, basically. So alpha class means single polarity, beta gamma class means both polarities, and beta gamma delta class means both polarities with significant unsustainably complex magnetic fields. Beta gamma delta class. It's going to resolve one way or the other. So here are weather forecasts. There's pressure and precipitation based on the GFS model. Hopefully you heard that. Son of clay. So strong storms here forecasted for South Carolina, still getting hit. We'll show some radar here in a minute. Let's show snow totals briefly. It's very snowy in the northern hemisphere to kick off spring. It might not look like a large extent of snow, the two-dimensional model, but let's take a brief look at what's going on with snow mass balance and snow water equivalent. They are very high. Expect an epic melt season indeed. Snow water equivalent still way above 1 standard deviation over normal. As you can see here, expect a lot of meltwater to be rushing your way if you're downwind from huge piles of mountain snow especially. Snow extent right in the middle of the meaty range from 1998 to 2011, and snow mass balance, not counting mountains, way up at the top of the range of the 1982 to 2012 average. So epic melt season coming. Here's our NASA GOES lightning mapper, and a crazy lightning here. I suspect that we'll have reports of additional storms causing damage and possibly mayhem. Does it count as mayhem if it's natural? You get the idea. Let's take a look at a real-time lightning map from lightningmaps.org and give it a minute to load as we are streaming live. Oh, before we go there, check it out, some tornado imagery. How about how about a plank of wood? A portion of a plank of wood speared through a car. That's a pretty good tornado image. Less than optimal conditions over large portions of Mississippi. These are going to be ones for the history book. And this is not the way you want to do car crushing or clearing out your curio cabinet. So sadly, not everybody has a basement, but a lot of people should. Especially if able. Some horrifying images there. Death toll was at least 25. There are some mammatus clouds. And do we have any current severe thunderstorms happening? Indeed we do. Let's see if we can take a look. We'll zoom in close for once since we are actually on YouTube. Oh, these look harsh. Those look like bad news. Bad news. Let's look at the visible on that. Some very suddenly forming storms there over Louisiana. Huge thunderheads appearing. You can see rapid cloud nucleation happening on the water vapor map. Also right on the coast of Alabama there. We actually can zoom in a little bit closer on that, believe it or not. You can see a series of fairly round cells forming there. Quite quickly. And the wind is howling outside my window. Seems like a great day to not be on the bike. I almost went riding today. And I decided that would be a terrible idea. It sounds like at the end of The Shining. All right, so let me finish out my demo. Let me look at your chats here for a minute. We'll actually display them on the screen. And again, I'll definitely respond to any that are super chats. Wow, we racked up $5. And we hope you dudes are not in the poorhouse on Croissant Earth. We only need to make an additional approximately 56 grand per year for this to be a profitable operation. No big deal. Thanks to everybody who has helped out, especially Smash Team, Son of Clay, etc. Oh, and we're glad you like the new colors. The new colors are because it's spring, so you got to have the spring pastel colors. Paint yourself up like an Easter egg, and so on. Ah, April Fool's Day birthday. Nice. yeah, I mean, thanks everybody for tuning into the YouTube live stream. Part of the reason why these videos are not typically done live to YouTube is because YouTube constantly demonetizes our live streams. So this one's probably demonetized. Let me check. You want me to show you? Do you really want to know? Because it does indeed matter to the channel. We are paid to make these videos. Kinda. Let me just check, as we're doing absolutely nothing controversial once again for our second live stream in succession. Let me just look. And it is indeed monetized. All right. Well, that's amazing. So, you know, nod to YouTube there. All right, so here's what happens at the end of the video. I do this recap where I show the U.S. Doppler radar, and then I show usually the 3.9 nanometer infrared radiation map because it's dark. And then I usually show the water vapor map as so. And then I say some tagline that doesn't make me sound like an ignorant, insane lunatic, delusional narcissist. I say a tagline that makes sense and maybe has some sort of positive undertones in it, as opposed to hypocritical insanity. And then I end the video. And then here's what I do. Yeah, we're going to show you the aftermath too, the aftermath. So what happens next is I end the live stream, and then check this out. I'm going to show you actually what I do for real. Then I go into OBS like this, and I have a window that pops up that's right here. That is my chat window. And that pops up, and then I see like comments from people like Tinman 1057 and Mike Bordages and other people who view on the Twitch live streams. Over here it's got my stream information because I use the same software to stream to YouTube and to Twitch. So fun fact there, I use OBS for that. It's so powerful. You could create a feature-length movie no problem with, I mean, 2 smartphones and OBS, and you could create you could do so much stuff with it. It's beyond belief. If you want to start producing videos like this, we hope you're able to forecast your own weather. So that's why we say a lot of the stuff we do. And then we end the video. And then our work is like about 2/3 done then, because we still have to download the video. So I've got to go to Twitch and download the video. And then I got to set it to private because it's only live when we stream it to Twitch. So, you know, that's the next thing I do is I go over to Twitch and I say download and I say unpublish because you're only able to see it when it's live. After that, it's done. So that's what happens. Then I bring up Adobe Photoshop and I make the thumbnails. So here's some insight into what happens with that, as it's always interesting. Here, let's give you some proper insight here. This is we're gonna show you how the thumbnails are made. So, you know, no trade secrets here, folks. No trade secrets. At least these are the trade secrets that we'll reveal. So, you know, just bring up Photoshop. And then once that loads, what we do is we go into OBS like this, and then I say full screen projector on, and then I go like this. I go and I take a screenshot of that. And then I close this down before I crash my computer. And then I go into Photoshop and I take my most recent daily space weather video. Let's go back a few days. Let's pick one that still has a headline. And now you get to see the making of a DSW video thumbnail. You see how gracious I am? I show you what goes on behind the scenes. And today, we're going to... Well, oh my God, it didn't work. Something went wrong for some reason. And I don't know, that works for some reason. Sometimes Microsloth does stuff. And I don't know why. And just clip part of this off here, right? This is today's Adobe Photoshop tutorial. And then I'll like, oh my God, get rid of that. What is all that stuff? Get that out of here. Take a lasso, trash all that stuff, and take what's on the screen and make it bigger. Because you want to have, for a YouTube thumbnail, folks, you got to have somebody should be spooked or shocked, or somebody has to be getting destroyed. Right? So you got to have all that. And then we'll move the title. And notice we've been eliminating our titles, right? Because why? We've been putting less information. How do you like that, folks? Less information at the Smash News Network, least busted name of news. Yeah, intentionally withholding information. How you like them apples? Not too much. Anyway, we're going to call this one I can't type words. I'm going to call it live. No, I'm not going to do that. That's ridiculous. That's just ridiculous. I'm just going to call it, I'm just going to make it say live. And then I'm going to make it 1,000 point. Is that big enough, you think? Or maybe smaller? Let us know in the comments. Should we make it smaller? Oh my God. We've got hidden underbelly. Abso-smurfly amazing. All right. Anyway, let's shrink this down. Like, how about only 900? There we go. That's 800? Just say when in the live chat. We're gonna make the thumbnail look spooky. Just for fun. I'm gonna do an extended. Man, oh man, I need like 600. There we go. Not 6,000. There we go. Perfect. 600. And let's make glowing lava letters. We're gonna mess with the layer, and we're gonna, let's see, how about we'll put a drop shadow with some red. Make it like more orange. Put an outer glow with a red color. Bevel and emboss. We'll add some more lava-y colors in there. What else? How about some more orange? There you go. There are your inflammatory letters. Let's see, stroke. Should we change that? That's cool. And then we're going to put, so the best thing to do here, by the way, is take something from the video. So, all right, I got one. I know what to do. I got this covered. Bring up the last frame on this. And then we're going to get rid of this background and make it dark instead of bright, which is, by the way, something you can know how to do with doing some basic stuff in Photoshop. There we go. Make sure the solar B field is hitting me in the face. And then we'll put, I got it. I know what to do. I got it. I know it. I got it. I got it. I know it. I know it. I got it. We're going to put a 171 angstroms wavelength. 2 megapixel image. We're going to put that over on the upper left, and that'll be today's daily space weather thumbnail. We don't try to game the algorithm with the thumbnails. We just try to make thumbnails that include some additional information to make the videos as dense as possible. And of course, I've said it a few times, our thumbnails contain more information than entire channels on YouTube. So we'll just kind of shrink that down a little bit. And let's clip this. I don't like it. Actually, we'll put it back. There you go. Now it's a date stamp showing the date of the time I clicked on that SDO image. So there you go. Then I just save my thumbnail. And look at the nice naming convention I have. It's totally simple. All I do is I just change the last letter. Now I'm on ZZZZZZZZZZ S Z-A SZA or something. Oh, wait, one more thing. I forgot to do a thing. So to make it look slightly more dramatic, I'll take the portion that is... Oh, wait. There we go. Oh, my God, what happened? That was horrifying. Never do that again. Holy cripes. What in the hell did I just do? I'm glad I saved that, because that was a mess. Godness, good graciousness. All right, there is one other thing I got to do, and it's take this layer, and check this out. We're going to, let's see, we'll put, how about, we'll spike some lens flare over here. Right about there. And there you go. Now it looks like that image is like illuminating, like burning my face off or something. That's perfect. We'll just turn down the brightness a little bit. Turn up the contrast. There we go. We made it extra dramatic because it's a YouTube Live exclusive. So there you go. Hopefully that's dramatic enough for you. And of course, YouTube recommends the videos based on how many people watch them all the way through. So the likelihood of that is 0%. exactly 1.2 of you have watched this video all the way through. Fun fact, our video thumbnails are typically PNG images. Now, to excite you with more fascinating stuff about how YouTube works, we'll actually update the video to include this thumbnail. So how do you like that? Editing the video while we make the video. It's a great reason for you to tell your friends and foes to tune into the channel. And I don't want to do that. I want to drag and drop. There we go. And there you go. So there's your new thumbnail. Hopefully that was exciting. Now, what we would do after this is that, oh crap, I vanished. After that, what we would do is we'd be in the process of uploading it to YouTube. We would then select when to premiere the video. We would send emails to the Smash team because one of our Smash team viewers recommended that, or requested that we include email alerts when we indeed go live. So that's a thing, smashomash.com/Smash team. We will also do that. You'll get an email push when we put up one of our videos, as people complained about not getting notifications. So then what would happen next is we would spend the next about 10 minutes getting ready to watch the video on YouTube with people like you. I mean, part of the reason why we made the videos in the first place was to simply view them on a larger screen. There was certain information I wanted to look at in greater detail, so I started composing the videos for my own my own data analysis purposes. And I figured I would share because there seems to be, shall we say, a bit of confusion about space weather on the internet. Hopefully things are getting clearer as time goes on. All right, so we can close out the video with, if you've got any requests, leave them in the chat. Otherwise, we will look at some current imagery of El Sol. And I'll close out things with one more musical ditty here. How about La Tour de Chance? That's one you can find all over the internet also, by the way. It's one of the biggest, the most listened to on YouTube, the La Tour de Chance. And that is the slowed down version. How about that? This is actually the version we typically play. I thought it sounded weird. All right. Be back in about 2 minutes to say farewell and thank you, our viewers, for tuning in. Thanks for the request, Robert. Unfortunately, we'll have to end things here. No Temple Strike today. However, you can find it on our playlists at youtube.com/smashomash/playlists. Thanks for tuning in to the Daily Space Weather. We'll see you soon here at the Smash News Network, least busted name in news. And may that solar wind be at your back.